Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. Well, in this hour, we have a special treat. We're going to talk to a world-famous psychologist, Dr. Michael Gazzaniga, author of a book that's really hard to put down. Who's in Charge? Freewill and the Science of the Brain. Did you know that you can split the human brain right down the middle? This is incredible, but yes, it's true. Epileptics who suffer from convulsions, sometimes you have to do a life-saving operation, cutting the left brain from the right brain. And then what happens when you have two brains that don't talk to each other sitting inside your skull? This is called split brain patients, and Dr. Gazzaniga is one of the world's leading figures in this whole subject. For example, if your left brain and your right brain are split from each other, this means that your left hand and your right hand don't talk to each other. So with one hand, you may shake somebody's other hand, but with the other hand, give them a left hook. That's right. This has actually happened when the left brain and the right brain don't talk to each other. And for that matter, what happens if the left brain and the right brain have different psychological impulses, personalities, and desires? Believe it or not, you can ask the same question to the left brain and the right brain and get two different answers. What does that mean for free will? Especially given the fact that one part of the brain could be an atheist and the other part of the brain in your same skull could be a believer. Do you go to heaven if you have two minds, literally two minds inside your own skull? This sounds fantastic, but it's right inside your head. You see, you have a left brain, you have a right brain. Your left brain and right brain talk to each other, so they check each other, so you don't have alien hand syndrome where your left hand may want to choke you and your right brain has to constrain your other hand. We have brains that talk to each other. But what happens to patients where the two halves of the brain don't talk to each other? Literally, can you choke yourself at night? This is something that split brain patients have to worry about, that they may actually strangle themselves at night. Well, once again, our special guest is Dr. Michael Gazzaniga, professor of psychology at the University of California at Santa Barbara. His book is called Who's in Charge? Free Will and the Science of the Brain.
I have to say, sometimes science is more exciting than fiction. I mean, some of these ideas, this idea of living in a pocket of three dimensions inside a higher dimensional universe, that's something that came out of the science. We weren't trying to find that. I mean, the equations gave that to us. So even this idea that there could be an infinite extra dimension of space because space-time was so warped, we weren't looking for that in the beginning. That came out of it. So I think there are some ideas that come out of just doing science that even of course we could have sat down and imagined that. But it's really quite exciting. I mean, these aren't ideas that I've read in science fiction. I mean, they're really even more exciting. And the idea is to really just get people excited.
You're listening to Science Fantastic with Professor Michio Kaku. Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to be talking about something that's perhaps the most mysterious and yet most familiar thing of all, and that is your mind. With us today is Dr. Michael Gazzaniga. He's the author of a fascinating book that is really hard to put down. The book is called Who's in Charge? Free Will and the Science of the Brain. We think that we are in charge of who we are. After all, if you do something bad, you get punished because, well, it's your fault. But what happens if you have a brain tumor or a stroke? Should we still punish people if it's not their fault? And for that matter, how much free will do we really have? Well, we should also point out that Dr. Gazzaniga is a professor of psychology at the University of California at Santa Barbara. He was recently elected to the National Academy of Sciences, which is the highest advisory body to the United States Congress, and he's a former member of the President's Council on Bioethics. So, Michael, glad you could be on Science Fantastic.
Thank you.
Okay, first question we always ask our guests is, when you were a youth, let's say a kid around 10 or 11 years old, what got you interested in science?
Well, my father was a physician, and he was always discussing how mechanisms worked in the body, and I suppose by osmosis that got into me. And then I really had planned to go to medical school, and then one summer, between my junior and senior year in college, I spent a summer at Caltech doing basic research, and that turned my head tremendously. And I realized I wanted to spend a life in research and switched and actually went to Caltech for my PhD.
Okay, and why the brain? After all, it was a black box for thousands of years. People didn't know anything about what made the brain tick. Why did you get involved in brain studies?
Well, I had read an article while in college by Roger Sperry, who then was my mentor, and he had written this article on nerve growth and how nerves get from one place to another. Is the brain built in a specific way, or is it built randomly and then experience shapes it, so forth? And he really addressed this problem. And he's the man that really fundamentally turned that around and kind of got the answer going in that question. And once you get your teeth into something like that, it's just very hard to let go. It's so fascinating. So I got interested in the brain early, and then when I actually went to work for him, switched my interest to what was then happening, which was the study of split brains. And so I started out with studying the phenomenon in animals, and then I had the opportunity to help launch the human program as well. So once you touch it, you're infected.
Yes.
You've got to go study it.
Well, Michael, you're world famous for doing these split brain studies. However, when you try to explain split brain patients to the average person, they say, oh my God, you're cutting the brain in half. So let's walk it through, okay, step by step. First of all, tell us a little bit about epileptics and why we have to perform surgery on these people.
This is a group of patients who have epilepsy. That means they go into generalized convulsions, and they're not controlled by medications, the patients that wind up being surgical candidates. And the notion is that the focus starts somewhere in the brain, and there's what's called the Jacksonian march. It starts in a place, and it spreads throughout the brain, resulting in a generalized convulsion. And so the simple notion was, well, let's say it started on the left or started on the right. If we cut the neural connections between the two half brains, maybe half the brain could remain seizure-free while the other one is convulsing. And then there would not be a generalized convulsion, and the person could maintain some level of consciousness and in control. So the notion, which was around for a long time, was if you could surgically divide the hemispheres, which means just cutting the neural connections between the two sides, you could achieve this medical goal. And so that's what it was all about. The work came up from work being carried out in animals, and there the question was more scientifically stated, which was, how does information from one side of the brain get over to the other? Is this the tract? Is this the system that sustains our ability to see evenly? When we look out straight ahead of us, we see both sides of the world very evenly. Something's integrating that information. What is it? And a series of experiments by Ron Myers and Roger Sperry showed that this was the corpus callosum, this thing that they cut. And so that body of information stood there, and then the obvious thinking with that going on in the animal world, what is the implication of this for humans? And then the thought that this might help in epilepsy was asserted and made by a young neurosurgeon, Joe Bogan, and calling on earlier work that had been done years before in Rochester. So there's a whole history, what I'm trying to say, to this story, and it came together in this marvelous research program that was launched at Caltech.
Okay, now when people hear about split brain surgery, they say, oh my God. However, isn't it true that the brain has no pain sensors? So you can actually remove large portions of the skull and actually cut the link between the two halves, and the person basically feels almost nothing?
Oh, yeah. You can carry out neurosurgery basically while people are awake. If you anesthetize the skin to make the incision to remove the bone flap and to get into the brain, if you just anesthetize those peripheral things, a patient could be completely awake. and surgery could be going on. That's not how it's done typically, but it is done that way. And sometimes when people want to establish where in the brain a particular person's, say, language and speech system is, in order to have that done in the traditional way, the person has to be awake. So, yes, there are no pain centers in the brain, in the pain sensors in the brain, so that the surgery on the actual structure itself is in no way painful, as opposed to, say, your somatic system.
Okay, now you go to any New Age bookstore, and you see all these books about left brain and right brain and train your right brain, and the left brain is supposed to be analytical and the right brain is supposed to be artistic. Is that a bunch of nonsense, or is there some kernel of truth to the fact that the left brain and the right brain really are a little bit different?
Well, they're definitely different in the sense of the most of the neural hardware that supports language and speech and analytic thought and all those sorts of things are predominantly in the left hemisphere. And there are specialized systems that put patterns of information in together so that you recognize patterns. And those seem to be specialized systems in the right hemisphere. So there's a distribution of capacities throughout the cortex. People work on that, and they define these areas, and they see the very individual variations and the patterns and all the rest of it. So that just becomes dramatic in the split brain patient in that it's only the information projected or presented to the left brain that can be talked about to anybody. The right brain experiences cannot be talked about because language is localized, usually only on the left side. So that fact generated thousands of interpretations about being left-brained or right-brained. And where it got crazy is that in you and me, we are intact. Our callosal system is working constantly, communicating information between the two sides of the brain. And that's the end of the story. It's not that one normally is only using their left brain or only using their right brain. It's a constant exchange of information between the two sides.
Okay, well, some of these New Age books say that the right brain is more artistic, is more holistic. The left brain, as you pointed out, is more analytical, and language is concentrated in the left brain. So is there any truth to this distinction?
Well, as I said, there is a grain of truth in the sense that the neural hardware for the language, speech, analytic processes seems to be predominantly managed by the left brain. And there are specialized systems for the apprehension of, say, visual information in its bits and pieces into a whole. That seems to be a process that is predominantly in the right hemisphere. And so to that extent, the metaphors have some weight to them. But when you say that a person is particularly right-brained or particularly left-brained, and the implication of that is that they can only be capable of one kind of thought or only be capable of another kind of thought, that gets where it starts to get iffy and fall apart. We all have these skills. You have an analytical language part. You have also this other part of your brain that allows you to navigate the universe because you take bits of information and put them together and you see objects and you avoid them and all the rest of it. So you are constantly using both sides of your brain.
Okay, now let me ask you the killer question that a lot of people want to know the answer to. If we have a left brain and a right brain, and they are integrated because we are whole, in split brain people, is there therefore two consciousnesses, two free wills, two personalities? Can you have two people living in the same skull?
Well, I'll give you two and raise you two. This is where there's a transition. This is where you realize that the split brain experiments gave us an insight into the fact that there are these specialized regions in the brain. And then when you take that, you realize, but there's really all kinds of specialized regions all over the brain. The brain is this vastly parallel and distributed system. So it's not that there are the surgical knife and presenting the disconnected left brain from the right brain allows you to test these two centers very nicely, and you kind of get the idea, well, gee, there seem to be two separate conscious systems here. they both can form and prepare for action, so you think they have, quote, two free wills if you think that way. On the other hand, when you get the larger picture, you see, well, actually there's hundreds of thousands of these modules all over the place. And it's really a multi-agent system that we possess. All kinds of systems are locally making decisions and carrying out actions. So the notion that you've presented two conscious systems is at one level, okay, you can say that, but in fact that's not how it probably works. Consciousness is highly distributed throughout the cortex and is probably very locally energized. So it moves from just two to multiple very quickly when you look at all the data. Does that make sense to you?
Yeah, now there's a famous scene in Dr. Strangelove, the movie, where the right hand and the left hand of this Dr. Strangelove don't communicate with each other, and one hand tries to strangle the body. So is that alien hand syndrome possible if you have a split-brain person such that the left hand and the right hand don't quite communicate?
So this is where it gets, you got to dive a little deeper here into the data. After you split the brain of a human, if there's no other brain damage associated with the patient we're studying, each hemisphere can rather easily control either arm and usually the hand as well, but not always. Not always the ipsilateral hand. Now, you take another patient who has the surgery, and they have additional brain damage from their earlier epilepsy or whatever their neurologic history is. That kind of patient can only control kind of the opposite hand. So the left brain can control the right hand, and the right brain can control the left hand. In those kinds of cases, you can get conflict going. You can produce conflicts by certain tests you set up, and even at just the everyday behavioral level, you can see where one hand wants to do something and the other hand kind of tries to reverse this. We saw this very clearly in our first patient we studied at Cal.
Okay, Michael, we're going to have to take another short commercial break, but after the break, we're going to continue our discussion of alien hand syndrome. What happens if the left hand and the right hand are at odds with each other because the brain has been cut right down the middle? Once again, this is Science Fantastic with Professor Michio Kaku. Our special guest today is Michael Gazzaniga, professor of psychology at the University of California, Santa Barbara, and the author of an exciting new book. I recommend it to everyone. It's called Who's in Charge? Free Will and the Science of the Brain. This is Science Fantastic with Professor Michio Kaku.
Hi, I'm Jack Gallant, professor of psychology at University of California, Berkeley. Here at Berkeley and in many other neuroscience labs around the world, we're starting to build computational models of the human brain that are going to accurately allow us to predict brain activity and allow us to reconstruct mental events, thoughts, internal speech, visual imagery, dreams. It's all future tech, but we're on the road to getting there.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Dr. Michael Gazzaniga, professor of psychology at the University of California, Santa Barbara, and he's the author of an exciting book, Who's in Charge? Free Will and the Science of the Brain. You know, we think that we're hot stuff. We think that we are in charge. We are the master of our destiny. But is that really true? What happens if you split the brain right down the middle and the two halves don't communicate with each other? Is it possible that the left hand and the right hand could have, in some sense, a will of their own? So, Michael, where we last left off, we were talking about alien hand syndrome. Let's say you're shopping or you're going to a store and you have the two halves of your brain cut so that they don't communicate with each other. Can one hand and the other hand follow different instructions?
The use of one hand, the behavior of one hand can reflect the moods, intentions, wills, as you might, of the opposite hemisphere. So you can imagine going down the food aisle and the left hand grabs the baked beans and the right hand grabs the rice. and that would reflect different preferences of the two. And you can see that kind of thing. You can produce that kind of thing in the laboratory. Or what we did many years ago in an experiment is get a set of items that we knew this patient was interested in, and we would have them rate how much they liked them on a 1 to 10 scale. And normally the hemispheres rate how much they like something the same, so they both have the same kind of preferences, okay? Then one day the patient was particularly agitated and kind of not really wanting to do our test and kind of just anxious. And we had the wisdom to let's run that test again where we evaluate if the hemispheres are on the same page about stuff. And we did, and we found out that they were wildly divergent that day. One positively evaluated objects, say like an apple, and the other side negatively evaluated it. So he was feeling some conflict, like he had mental systems in him that were just simply one liking something, one didn't liking something at that moment, and it produced a conflict. And I think that's a common experience of all of us. We're vacillating about a choice of something. We're flipping between one positive evaluation and negative evaluation of it. And so what the split brain does is give you an insight into those kinds of things are real and they're brain-based, and we can see them because of the nature of the split brain. But you then say, well, that obviously goes on to us. We can be of two minds about a particular object, and that gives rise to conflict. And so you see it very nicely in the experimental situation, but then you say, gee, that looks like it's a good model for us as well.
Now, there was one episode I was reading in your book where you asked somebody what they want to aspire to, and they want to go to college and get a degree and so on and so forth. But then you talked to, quote, the right brain, which cannot speak, but that right brain can use Scrabble letters to make Scrabble words. And then you asked them, what do you want to be? And the other brain, the right brain, wanted to be a race car driver. So isn't it possible, therefore, you can have two personalities, one personality, the dominant one that can talk, says, no, I got to go to college, have a good job. And the other one, being more holistic, that cannot talk, but using Scrabble letters, says, I want to become a race car driver. Could you elaborate?
Again, the split brain allows you to see that in all the clarity you just described, but then you walk that back to you and me, and what it's saying is that you can have two different kinds of mental stances with respect to the world on any given moment, and at one time you sort of feel one way, and at another time you sort of feel another way. And those reflect actual brain mechanisms that are battling, as it were, for attention. And that gives you a cue to how the brain is organized and how it functions. So, yes, I think most of us are continually wondering what we're going to do when we grow up. And why is that? Why do we have alternative approaches? Why do we have different feelings? Sometimes I would prefer to spend a week out in my garden, and other times I don't want any part of my garden. I want to be in writing something or whatever. And that just reflects all these different systems that we have that are concurrently running this multi-agent system that you and I possess. That's just how the brain works. So again, the split brain gives you an avenue into seeing these things. And you see it, it's kind of in some sense, a research opportunity, a research tool to understand the more general question of mental life.
Okay, Michael, we have to take a short commercial break. But after the break, I want to ask you a question that we would also like to ask another doctor, Dr. Ramachandran. Dr. Ramachandran claims that he has a split-brain person who is an atheist in one side of the brain, but a believer in God in the other side of the brain. And then Dr. Ramachandran asked the question, will he go to heaven if one half of the brain is an atheist and the other half of the brain believes in God? Well, let's ask that question after the break. Well, once again, this is Science Fantastic with Dr. Michio Kaku. Science Fantastic.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. Lately, I've been reading a book. In fact, it's kind of hard to put down. The book is called Who's in Charge? Freewill and the Science of the Brain, and we're very delighted to have with us the author of that book, a world-famous psychologist, Dr. Michio Kaku, professor of psychology at the University of California at Santa Barbara. He was recently elected to the National Academy of Sciences, which is the highest scientific advisory body to the United States Congress. And he's a former member of the President's Council on Bioethics. Well, Michael, where we last left off, we were talking about the fact that the left brain and the right brain in epileptics can be split surgically, and they have somewhat a mind of their own. Dr. Ramachandran, who also has investigated these people, claims that he had one patient, and you ask him a question, do you believe in God? The left brain said yes, and the right brain said no. And then Dr. Ramachandran asked the question, well, is he going to go to heaven, given the fact that he is apparently conflicted on this question? Any thoughts?
Dr. Ramachandran is a very clever man. I know him, and I don't know where he was going with that, but I want to tell you that also a philosopher wrote a book on this sort of related idea, Roland Puccetti from Dalhousie, and there it turns out a split-brain patient violently attacked his wife with one hand and then went to trial and for this, and the split-brain syndrome became apparent in the trial, and the jury happened to judge that he wasn't guilty for reasons of he had this surgery and so forth and so on. And so he was dismissed, but the end of the book shows the patient, the person who was charged with the crime, didn't think that was just and grabs the bailiff's gun and shoots off the hemisphere that was responsible for killing his wife because justice had to be carried out. So the point is that these stories give rise to these phantasmagoric scenarios, and I think they're just let us think about things, but I don't know how to answer what the implication is. It was all stories to try to get people to see that all of this richly connected mental life we have is generated by the brain and parts of the brain, and therefore we have to think about it.
But I mean, if you shoot the other side of the brain, don't you both die? If you shoot one side of you commit suicide, right? You're connected like Siamese twins.
No, don't think too deeply about it.
Okay.
It was just, this was many years ago, and this was just when the split brain sort of findings were coming out, and he was trying to rally his philosopher colleagues into the importance of it, and he wrote this little sort of little book on it.
So. Okay. Well, Dr. Ramachandran also mentions another thing. He claims, and I want to get your opinion on this, that people who are bipolar, maybe, just maybe, is because the left brain tends to be more manic, more optimistic, and the right brain checks the left brain. But maybe, he says, in bipolar syndrome, when people oscillate between optimism and pessimism and back and forth, maybe the left brain is getting out of hand and becomes manic. Well, we have to take a short commercial break, but after the break, we're going to continue a discussion, a fascinating discussion about free will. Our special guest today is Dr. Michio Kaku, professor of psychology at the University of California at Santa Barbara, author of an exciting new book, Who's in Charge? Free Will and the Science of the Brain. And once again, this is Science Fantastic with Professor Michio Kaku.
I have a really fun mental illness, you guys, called bipolar disorder. Thank you. Yeah. And when people find that out, they always ask me, oh, are you going to be okay? Which really means, oh, am I going to be okay? And people with bipolar disorder, we're a lot like polar bears. Because sometimes I want to go to the mall with my friends, and sometimes I want to maul my friends.
You're listening to Science Fantastic with Professor Michio Kaku. This is Science Fantastic
Welcome back to Science Fantastic with Professor Michio Kaku. Our special guest today is a world-famous scientist, Dr. Michael Gazzaniga, author of an exciting book that's very hard to put down. Who's in Charge? Free Will and the Science of the Brain. Well, Michael, where we last left off, we were talking about the split brain patients, and some people like Dr. Ramachandran claim that maybe, just maybe, bipolar syndrome, the people who oscillate back and forth between pessimism and optimism with wild swings, maybe it's because the left brain, left to itself, tends to be a little bit manic and optimistic, and if it runs amok, then it could create sense of omnipotence and sense that I'm number one, and then, of course, you crash when the right brain checks the left brain. Is that a valid theory, or is that just speculation?
Well, it's clearly speculation, but it's rich speculation. I really don't have a sense of whether that's going to play out or not. We're beginning to learn that there's very heavy involvement in regions of the left hemisphere that seem to be very active in depression, and whether they're being held in check by some other systems, I just don't know. I don't have a sense of that problem, so I won't answer.
Okay.
One way or the other.
Let's get right to free will. You claim that when the left brain and the right brain have to confront the contradiction that there really are two centers of activity, the left brain basically makes things up. It's a confabulator, you say. It's the interpreter. Explain, what do you mean by the left brain being the interpreter, trying to paper over all these apparent contradictions?
It took us a long time to ask our split brain patients the right question almost. And what it was we were doing tests where we could get the left brain to make a simple choice between two objects, and we could get the right brain to do the same thing at the same time, make another choice. And finally we asked, when the hands were pointing to these different answers, the right hand was pointing to the correct answer for information we gave the left brain, and the right brain was correctly controlling the left hand. We said, so why did you do that? And really, the left brain only knows why it did its thing. It really doesn't know why the opposite hand was choosing, because it's disconnected from that information. But what we saw was that the behavior was out for everybody to see, and so what we do is we made up a story to be consistent, so that if we choose two things and we know why we chose one of them, but we really don't know why we chose the other one, but we did, we instantly sort of make up a story. And it turns out this property of interpreting the world to keep a narrative going that makes sense, this thing that does this is something in the left hemisphere. It's called the interpreter. That's what we've just dubbed it. And it's everywhere, and it's everywhere in our lives. So even though we have this multi-agent system within us, all these little brain areas that are working in this vastly parallel distributed system, making decisions, carrying out things, there's this thing that's watching all of this and trying to make up a story to make sense about all the actions we carry out. And that's this very unique thing that spins our story, develops a theory of ourself, and it's a very important aspect of the human condition.
Now, humans always ask the question, why? Why did that happen? Now, animals don't do that to the best of our knowledge, but humans always ask the question, why? If it rains, what did we do to cause it to rain, right? So you're saying that this confabulation process is really inherent in the brain. The brain is constantly asking the question, why?
Right, exactly. And it's in a particular part of the brain that does it. So if you try to ask, you have to see this disconnected right hemisphere, for example, that is usually silent and doesn't say anything. You can do tests to say, well, does it have an interpretation of the world? Does it make up stories? And the answer is, it looks like it does not. So this interpreter, is specialized and localized in the left brain. It's not a right brain phenomenon. It's not duplicated. And so it's a very big deal, and it's almost a defining element of the human condition to possess this capacity.
Now, let me also ask you a question about free will. It was Sigmund Freud years ago who called the superego the part of the brain which says, don't do that, it's your guilty conscience. However, if you have a tumor in that area of the brain, perhaps you run amok and become a bank robber or whatever. First of all, is there a part of the brain that corresponds to a superego, a guilty conscience? Is there such a part of the brain?
Well, I think we build up a narrative of do's and don'ts from experiencing the world, and we build up a model for how we want to behave, and we all possess these models, and we consult them when we're about to plan a future action. And in that sense, if you want to call that something like ego or superego or what have you, you can go ahead and do that. But what it is, we are information gathering machines that are trying to make decisions and planning actions. That's what we do, right?
Mm-hmm.
And so once you cast it that way, sure, you're going to have mechanisms that allow you to do that and form hypotheses about future actions you want to take and the payoffs for those. And that's how the scientists come in and evaluate what it is that makes the human mind and brain work the way it does, and they come up with that model. Now, in that model, you get into this question of free will. You say, well, okay, now where's free will? And you just have to ask yourself a couple questions. First of all, what do you want to be free from? Do you want to be free from physics and chemistry, the natural world? I don't. Those are the processes that allow all these things that we're understanding to work. And then second of all, if you just imagine that you are a roboticist and you are thinking about how to build the perfect robot. And as you know, the robots are getting kind of having a sense of autonomy from the designer. They're getting to be able to do more and more things. And that means that they're getting more sophisticated in processing information and making judgments and planning actions. Well, at what point does a designer say, all right, now we just need one last thing for this robot because it's really good. We got to put in the free will chip.
Okay.
What does that
Michael,
mean?
Unfortunately, we've run out of time, but you raise all sorts of delicious paradoxes and intriguing avenues of thought. Once again, the book is called Who's in Charge? Free Will and the Science of the Brain. So, Michael, thank you so much for being on Science Fantastic.
Thank you very much for having me.
Once again, our special guest was Dr. Michael Gazzaniga, professor of psychology at the University of California at Santa Barbara. And again, the book's name is Who's in Charge? Free Will and the Science of the Brain.
You're listening to Science Fantastic with Professor Michio Kaku. Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And today, we're going to talk about one of the most earth-shattering technologies of all. And that is what happens when we can create, well, another human. Another human in the form of a robot, another human in the form of a clone, whatever. What happens when we have the power of a god, the ability to breathe life into the inanimate? Well, with us today to discuss this philosophical and scientific question is a physicist. He's Philip Ball. He has a bachelor's degree in chemistry from Oxford University in England. He got his PhD in physics from the University of Bristol, and we're very delighted to have him with us today all the way from London, England. And he's the author of a new book called Unnatural, the heretical idea of making people. We should also point out that Professor Ball is a freelance science writer. He writes for Nature magazine, in fact, for over 20 years. He's lectured at the Victoria and Albert Museum in London, also at the NASA Ames Research Center. He's written for the New York Times, The Guardian, The New Scientist, and he's a regular columnist for science for Prospect magazine. Well, with us today, once again, is Philip Ball, who will talk about the idea of, well, making people. What will it be like when one day we can create clones of ourselves? What happens when one day we have the ability to create artificial beings or robots? First of all, if you want to get a background for this kind of concept, then you may want to get a copy of my book, Physics of the Future. I have a whole chapter on what happens when we have intelligent robots that are, quote, as smart as us. And we should also point out that Physics of the Future was a New York Times bestseller and voted as one of Amazon's top 100 books. Well, if you read the Bible, you know the mythology concerning how God took clay, breathed life into clay, and created human beings. But did you also know that the reason why God expelled Adam and Eve from the Garden of Eden was because the apple was just not the apple of sin or sex. It was the apple of knowledge. Knowledge, the knowledge of immortality, the knowledge to become a god. And for that, God said, well, we have to kick Adam and Eve out of the Garden of Eden. Well, fast forward the videotape, and now scientists are on the verge of perhaps one day being able to create life in our image, being able to clone a human being. Now, don't believe it when somebody announces in the press that they've been able to clone a human being. No one has been able to do it at the present time. We can clone pets. We can clone dogs, cats, horses, thoroughbred horses. We can clone farm animals. But nobody has ever successfully cloned a primate, let alone a human being. However, it's inevitable. At some point, some enterprising scientist will, in fact, clone a human being and then, out of a test tube, create a carbon copy of yourself. And for that matter, maybe one day somebody will create a robot with all the intelligence of a human being. What happens then? Well, that's why this whole concept of, quote, making people, unquote, is a fascinating one, and it goes all the way back to legends. All our ancient mythologies talk about breathing life into clay, creating human beings, and then human beings creating carbon copies of ourselves. It's a theme that's found throughout mythology. For example, the Greek god Zeus was very angry at humans because humans got the gift of fire from Prometheus, and Zeus wanted to punish humans. He punished humans by getting Vulcan, the god that forged the steel of Olympus, and Zeus ordered Vulcan to create a robot that could disguise itself as a human to unleash chaos in revenge for what Prometheus did in giving the gift of fire to humanity. Well, Vulcan went to his forge and forged a robot human. It was a beautiful woman robot called Pandora. Pandora was so lifelike that, well, she was indistinguishable from a beautiful woman, but she unleashed the gods of chaos and panic and fear on humanity. So the whole idea of being able to create an artificial person goes all the way back to our original fears of the gods. Not to mention, we also have the mythology of Pygmalion. Pygmalion was a sculptor who one day fell in love with his own creation. He created a beautiful woman, and then he fell in love with his statue, spurned all sorts of entreaties from his fellow human being who were worried that he was wasting away, pining for this statue. Well, Venus took pity on Pygmalion, breathed life into Pygmalion and into the statue, and the statue became a woman. Well, George Bernard Shaw, the playwright, was so fascinated by the story that he created My Fair Lady, a Hollywood movie in which Audrey Hepburn plays a, quote, gutter snipe, unquote, who can become a lady simply by changing her diction. And so here's the question. Is it possible that with proper nurturing and education, we can take clay and make that clay into a lady? Some people think that in the future, maybe humans will create artificial women, artificial men that will replace men and women. And who needs to go on a date when all you have to do is dial up a robot? Well, these are some of the things we'll be talking with our guest, Philip Ball, when we talk about the question of artificial people and making people. But there's also a morality tale, and that is, we all know the legend of Frankenstein. Frankenstein was actually a novel written by a teenager, Mary Shelley, the wife of the famous poet Shelley, and she wrote the outline for Frankenstein one evening on a dare, and that outline became a novel, which in turn evokes some of the greatest themes, not only of Hollywood, but also of mythology and storytelling. What happens when technology bites back? What happens when we become so proud of ourselves, so arrogant, that we think we can create an artificial human and get away with it. Well, that was the morality tale Frankenstein, and then Aldous Huxley wrote Brave New World, a hideous world where you could basically mass-produce Frankenstein, mass-produce embryos in a hatchery to create a controlled society. Well, once again, with us today will be Philip Ball, author of the book Unnatural, the heretical idea of making people. We're going to talk about cloning. We're going to talk about mythologies. We're going to talk about robots today on Science Fantastic.
Want to explain why you were hiding at the crime scene?
I was frightened.
Robots don't feel fear. They don't feel anything. They don't get hungry. They don't sleep.
I do. I have even had dreams.
Human beings have dreams. Even dogs have dreams, but not you. You are just a machine. An imitation of life. Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
You're listening to Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to go back to the world of mythology, legends, and also the future. Some people think that perhaps the pivotal event in human evolution will be the time when we can create a carbon copy of ourselves, an artificial being, not just a robot, but an android that is indistinguishable from a human being. It goes all the way back to mythology, Greek mythology, all the way back to the legends of Frankenstein. And for that matter, what happens if our creation becomes stronger, better, and smarter than us? We'll say a few things about the singularity as well. Well, with us today to talk about this is a science writer, Philip Ball. We got him all the way from London. In fact, he has his bachelor's in chemistry from Oxford University, a PhD in physics from the University of Bristol, and he has a new book out called Unnatural, the heretical idea of making people. And we should also point out that he's been an editor at Nature Magazine, been associated with Nature Magazine for over 20 years. And Nature Magazine, of course, is one of the premier journals in science. So, Phil, glad you could be on Science Fantastic.
A pleasure. Thanks for asking me.
Okay, well, you have a PhD in physics. So what got you interested in science as a youth and then science writing?
Well, I guess I was drawn towards science when I was younger, and for the same reason that a lot of people are. I had good teachers. It was basically that. In retrospect, I realized I could have gone either way. I would have happily studied music or literature. But my science teachers, particularly my chemistry teachers, were inspiring, and it was for that reason that I chose, first of all, to study chemistry. And then I found myself doing physics, which was a bit of a jump, but I'm very glad that I did the two. But then I guess, as I started to do science at the research level, I realized that although I could do it, I was never going to change the world this way. I was never going to be particularly fantastic at it. And I could see myself getting narrower and narrower if I stayed in research. That's the problem that a lot of people face, particularly today. Whereas I was, interested in trying to get broader and broader, and writing about science seemed an ideal way to do that. I was very lucky to get a position at Nature, as you said, which opened up a whole new areas of science. It was very important to try to read very broadly about science in order to do that job. And that really launched me in science writing as well, because there are opportunities to do that at Nature.
Well, you've written across the spectrum. You've written about molecular biology. You've written about cosmology. And today we're going to talk about your book, Unnatural, the heretical idea of making people. So what got you interested in the whole question of, whether or not we can breathe life into clay the same way that in mythology, God breathed life into clay and made us?
Well, of course, as you say, this is a very old question. I think what drew me to it is the same thing that draws me to most of the things that I write about, because I'm particularly interested in how science interacts with the rest of culture. And I put it carefully like that because I always want to stress that science is a part of culture, just as the arts are. It informs how we think culturally about all kinds of issues. And I'm interested in that interaction, in how science sort of feeds into the popular culture and what is made of it there, and how sometimes that feeds back into science. And I've been interested in looking at interactions between science and the arts, and science and music. And this was another area, because I think one thing that interests me in particular is how some of the very old myths and legends that we have informs the way that we still think about science. In fact, some people would say in some ways science fulfills some of the roles that those old stories used to fulfill in telling us, giving us answers to where we come from, where we're going, why we're here. So I was interested in that general area. This one in particular, this question of making a human being, seemed to me to be a particularly powerful idea that has constantly been examined in myth and literature and the arts. And it seemed to me, and one thing I argue in the book, is that those ideas, because they are so deeply rooted in our thinking and in our cultures and our stories, they are still very much informing the way we think about some of the new technologies we have today for doing things that look a bit like this, that look a bit like making humans, or at least making parts of humans. Things like assisted conception, reproductive technology, stem cell and tissue engineering, all of these have strong resonances with these very old ideas about making humans and these very old taboos and prejudices about it. And it seems to me that those ideas are still very much around when we grapple with the ethics of these new developments, as we have to. I mean, there certainly are important ethical and moral questions. So I wanted to just sort of open that up and see how those old ideas have informed and colored the way that we think about these issues today.
Okay, well, if you look at ancient mythologies of all civilizations, they have this mythology that God essentially breathed life into clay to create humans, and some people think that maybe we are striving for divinity, that perhaps we also want to breathe life into clay to create a carbon copy of ourselves, and perhaps that's the reason why in Greek and Roman, Chinese legends, we have this recurring theme of creating artificial beings. What are your thoughts?
Well, yes, of course, it's true that the idea that one can do this, can essentially breathe life into inanimate matter, that goes right back to lots of creation myths, because we were faced with the question of, how on earth it was that we came into being in the first place, and before people had an idea of, a clear idea of an evolutionary process, often the answer was that, well, God or the gods must have somehow done it, must have taken, it was often said that they took clay or mud and formed it into some sort of body and then breathed life into it. And this is one idea, this is one of the predominant ideas in Greek mythology for how humans began. But there, it's quite interesting that was portrayed as quite a transgressive act, because according to some legends, Prometheus had a role in this. We kind of tend to know that Prometheus in mythology gave humans fire. He actually did more than that. He was said to have given humans all their technologies. And in doing that, he also gave them the ability to plan for the future. He gave them much more power to take control over their destiny. In some versions of the legend, Prometheus himself was responsible for actually making, or at least finishing off, human beings themselves. And of course, this was something that the Olympian gods, that Zeus didn't approve of, and so Prometheus was consigned to this terrible fate of having his liver pecked out daily, tied onto Mount Olympus. And so there was this idea that creating beings in this way there was something suspicious about it. There was something sort of reprehensible about it. And also, I think that what went along with that in the Prometheus legend was a general wariness of technology, quite across the board. The fact that Prometheus was the one who gave us this technology, and he did so against the will of the gods, means that there's something a bit suspicious about technology itself. And I think that's also something that carries through in a lot of these legends and a lot of thinking. Even today, people are wary of a lot of aspects of technology.
Well, according to Greek mythology, we have the legend of Pygmalion, where Venus actually breathes life into a female statue, and that statue turns into a real human. Well, then the author, George Bernard Shaw, rewrote the legend, and it became My Fair Lady, adapted by Hollywood, starring Audrey Hepburn. And there we have a mentor, Henry Higgins, who then, like a statue, molds Audrey Hepburn into becoming a lady. So this legend, the legend of artificial people, actually goes right to the core of some of our wishes and desires of making, well, a desirable mate. Do you think that could also be a morality lesson?
Yeah, I think there are all sorts of interesting themes there. I mean, one of them was purely this idea that it was possible to animate statues. And it seems that part of that idea comes from the fact that in ancient Greece, there were some inventors and technicians, as we would call them, and technologists who were able to make statues move, who were able to create automata or just sort of mechanical devices that seemed to move and sometimes to speak or to make sounds. And to people in ancient Greece, this ability was kind of akin to bringing something to life. There wasn't a clear distinction between them. And so that's part of where that legend comes from. But I think you've touched on another interesting thing, the fact that sex comes into this as well.
Phil, we're going to have to take a short commercial break, but after the break, we're going to continue to talk about your book, Unnatural, the heretical idea of making people. Is it possible that one day we can create robots? What about clones? What about creating something in our own image? Well, once again, you're listening to Science Fantastic with Professor Michio Kaku. So stay tuned as we continue to discuss the question of making people.
They say everyone has a double somewhere. But imagine an exact duplicate of you. There's the science.
It's a significant medical breakthrough.
The ethics.
I think all human cloning should be banned.
And the politics.
I think the government should take a role in this.
To understand the issue, we must first understand cloning.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Philip Ball. He's been an editor at Nature magazine, been associated with that magazine for over 20 years. Well, before the break, we talked about ancient mythology. Now let's talk about medieval legends and the people during the Renaissance who were fascinated with robots. Leonardo da Vinci, not only did he paint the Mona Lisa, but in his notebooks, he actually drew the blueprints for a mechanical knight. So tell us a little bit about now the Middle Ages, when inventors began to actually create realistic robots that could play melodies and entertain guests.
Right. Well, actually, there are two themes here, really, because before that, there was an idea in the Middle Ages that, but through alchemy, one could make a human-like being. That this was basically a chemical process that you could cook up in a glass vessel, and you could make a tiny being that would be intelligent and would have special powers. But at the same time, as you say, there were people who were starting to get very, very skilled at making mechanical devices that seemed able to move around. Some of the reports of these are hard to believe now, that it's said that people made tiny little flying birds and even bees and insects that could buzz around out of brass and wood. But clearly they were doing something of this sort. They were making, mechanical things that could move. And by the Renaissance and the early Enlightenment, by the 17th century, this had become a fine art. And people were making really impressive automata at that stage that could do all sorts of things. In the 18th century, a French engineer made automata that could play the flute and that could even write their names or draw a few simple sketches. They were, if you like, they were sort of programmed to do this. They could only sort of draw 4 different pictures, but nevertheless, this was astonishing. They looked incredibly lifelike, and large audiences would go and pay money to go to the chambers of these people and go and watch these machines in action. And they would be having serious discussions about whether actually, in some sense, they were alive. this sort of culminated in the early 19th century in a famous fraud where someone had alleged to make a robot dressed like a Turk that could play chess. So the idea here was that it wasn't just something that could move. It had intelligence. It could actually figure out which moves to make. Now, it turned out later on that the way this was working was that there was a chess master, a human chess master, hidden in the cabinet of this device that was operating, that was able to see what was going on and operating the machine. But it says something about where this technology was going, that people were, before that, they were really ready to believe that it was possible to make a device that could think. And so it was really, to their minds, just one step away from something that could genuinely be thought of as living.
And wasn't there also the Jewish legend of the Golem?
Yeah, now that's another strand, which goes back to what we were talking about before, about the idea of God, or the gods making humans from mud and breathing life into them, because in Jewish tradition, it was possible for people to do this as well, and they couldn't do it as well as God could do it. But what they could do was to make one of these creatures called a golem. The golem, the word itself in Hebrew simply refers to a sort of unformed being, and in some texts it seems to be referring to an unborn child, an embryo, which hadn't been sort of fully finished. But the golem in Jewish legend was a creature made of clay, human-sized or even bigger than human, that could be activated, animated by a kind of a magical process to breathe life into it, and that could act as a domestic servant.
Now let's talk about what happens when technology goes berserk and bites back. We have the Frankenstein monster, written by a teenager, Mary Shelley, when she was around, I think, 18 years of age. And then we have The Brave New World of Aldous Huxley. So tell us a little bit about Mary Shelley and Frankenstein.
Well, Mary Shelley's book is extraordinary and very important, really central, I think, to the developing idea of making human beings for various reasons. For one thing, Frankenstein wasn't made by magic. Frankenstein was made by science, by medicine. And so this was a suggestion that, science itself might lead us to this end. And also, of course, it wasn't a good end. Frankenstein went bad. So, this is what Frankenstein sort of left us with, that if we tamper with these things too much, then there are going to be bad consequences.
Okay, Phil, we're going to have to take a short commercial break, but after the break, we're going to continue our discussion about Frankenstein, Brave New World, and what about modern-day cloning? Are we going to have the power of a god to create life in our own image? Stay tuned as we continue to talk about Frankenstein, Brave New World, and the unnatural. Stay tuned.
But now, I'm going to turn that ray on that body and endow it with life.
And you really believe that you can bring life to the dead?
That body is not dead. It has never lived. I created it. I made it with my own hands from the bodies I took from graves, from the gallows, anywhere. Go and see for yourself.
You're listening to Science Fantastic. Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. With us on the line all the way from London is Philip Ball. He's a freelance writer with Nature magazine, got his bachelor's in chemistry from Oxford, a PhD in physics from the University of Bristol, and he's the author of an exciting book called Unnatural, the heretical idea of making people. So where we last left off, we were talking about Mary Shelley and Frankenstein, and wasn't that book essentially really had a sea change with regards to the whole debate, right?
Absolutely, yeah. Because as I was saying, it really brings science into the heart of this. So it's not magic anymore that is being used to make these creatures, it's science. And that's something that we also start to find when these ideas are explored in the early 20th century, most notably in Aldous Huxley's Brave New World. Again, it's science that is making these things, not by patching a being together as Victor Frankenstein did, but now by growing them in test tubes and jars, but from fertilized eggs. So this was a kind of an industrial IVF. And that's one of the key insights in Huxley's book, that whereas Frankenstein is just a lone person who creates this single creature, Huxley suggests to us that actually making people in the future is going to be done on an industrial scale. It's going to be done to create entire societies.
Well, as I recall, in Brave New World, not only do they have industrial-scale test tube babies, but they would deliberately deny oxygen to these embryos to create mental retardation, to create levels of slaves and servants. So you had the alphas who were perfect and destined to rule society, and then I think you had the deltas and epsilons that were retarded and became basically slaves and maids and butlers and things like that. So we're talking about not just test tube babies, but basically creating a nightmare of a society based on retardation, right?
Well, we're talking absolutely about social engineering, basically. And this was it has to be said, both in some ways the hope and the fear associated with reproductive technologies, that some people, including Aldous Huxley's brother Julian Huxley, believed that these new technologies were necessary in order to bring about eugenic social engineering, which now, immediately sort of sends out bad connotations. But at that time, a lot of biologists felt this was the only way to prevent a decline in the gene pool, to make sure that, you had enough sort of smart people having offspring. And so they were enthusiastic about it. But others, of course, were very worried about this prospect that social engineering could be used to basically sort of tailor a society according to, the ruling person's vision. And this is something that is still with us, and that still, you still see fears expressed about not so much IVF now, but about cloning, that somehow cloning is going to be used in this same way.
Okay, let's take another short commercial break, and after the break, we're going to talk about cloning. Once again, you're listening to Science Fantastic with Professor Michio Kaku. Stay tuned.
It's alive. It's alive. It's alive. It's alive. It's alive. In the name of God. Now I know what it feels like to be God.
Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about a book. It's called Unnatural, the heretical idea of making people. With us today is Philip Ball, associated with Nature magazine, one of the premier journals of science for the past 20 years. He's been a writer and editor at Nature magazine, and he has a book, Unnatural, the heretical idea of making people. Well, when we last left off, we were talking about Brave New World. As I recall, that novel was set 600 years into the future, and yet much of that technology has been with us for several decades, except for cloning. So even though once in a while somebody claims to have cloned a human being, most of that is nonsense. We haven't even cloned a primate, let alone a human yet. But do you think that it's inevitable that sometime in the future we will clone humans? And what about the ethical and societal implications of that?
Well, yes, I guess I do think that it's inevitable that at some time we will. That's not to underestimate the huge technical difficulties involved, let alone the moral and ethical questions. But I think that it's likely to happen, and that it's something that we're going to have to grapple with. I also think that when it happens, a lot of people will be as surprised that the cloned person is just a normal child who, will, I think, grow up in a normal family, or at least one hopes so, as they were when the first IVF baby, the first test tube baby, was born. That really there will be nothing, strange about a clone, nothing sort of robotic or spiritually vacant in the way that clones are often portrayed in novels and in sci-fi. So, in that sense, I think it's not something to be so terribly afraid of. But there are clear possibilities for cloning being abused. And, first of all, the first question one needs to ask is it safe? And, at the moment, no one has any idea whether it would be safe to clone a human being, what the long-term implications would be, except to say that, we have experience with other mammals, with, of course, Dolly the sheep, and now with several other kinds of mammal, who, don't seem to have any obvious serious long-term developmental or physiological problems necessarily, but through having been cloned. So, it may be that that questions of safety, won't turn out to be a hurdle that we can't pass. But clearly there are important moral and ethical questions. And I think, for my mind, the first one is not so much, is it right or wrong to clone a human being, but why would you want to do it? What good reason could you have for wanting to produce a human being that way rather than, say, by normal IVF? Now, it's possible to come up with reasons to do with, for example, the chances of inheriting genetic diseases, but they're not easy. It's not easy to think of a situation where cloning would be the best option, even if that were available. And one thing that, of course, that people are worried about is that cloning will be done for egotistical reasons. It'll be done by people who just want to see copies of themselves made in some kind of deluded belief that this will somehow give them a kind of immortality. That's the kind of thing that we need to protect against.
Yeah, personally, I think the whole issue of cloning has been overblown by the press. We'll simply get used to the fact that a tiny fraction of the human race is clones, because who's going to clone? Maybe rich people, right? Rich people with no heirs, or rich people with no heirs they particularly care for. They will simply give themselves money as a child to start all over again, and that's probably going to be it. I don't see that much of a market for cloning.
I suspect that may be true, although it's interesting that you say they'll give themselves money as a child to start over again. I think that's really how they see it. It'll somehow be themselves that is being perpetuated, whereas, of course, it's just a separate individual entirely.
Yeah, that's right. If you clone Hitler, you just get a second-rate artist.
Yeah,
now,
exactly.
Now, let's move on, because we just have a few minutes left in this show. Let's talk about what happens when we fast forward the videotape, maybe 50, 100 years into the future. No one knows how far. And let's say our mechanical contraptions get increasingly intelligent until they become as intelligent as us and maybe even smarter than us. At that point, some people think that maybe our robots will throw us in zoos, throw peanuts at us, make us dance behind bars, just like we make bears dance behind bars today. So what are your thoughts about what happens when our mechanical creations become smarter than us?
Well, in some ways, I think this is a separate question from creating human beings because, when we're talking about cloning or IVF, that's really all we're doing. Now, of course, people do talk about whether if you have those technologies, you can also use genetic manipulation to make those individuals better, smarter.
Homo superior.
Yeah, exactly. But, then you also have the possibility that artificial intelligence, that computers will become smarter than us. I think if they do, they'll be smarter in different ways. I don't think, to my mind, in the foreseeable future, I don't think we're going to make humans a kind of a sort of virtual, we're going to make computers a sort of virtual human being. I think it'll be a different sort of intelligence, just as it is now. They won't necessarily be more creative, more inventive, or anything. Maybe they'll just do the hard work for us. So I'm personally not too terrified that we're going to end up in a Terminator-like future.
Now, some people think that maybe we should just merge with our creations. What are your thoughts? We have to wind up right now.
Well, I think that that's misconceived simply from the point of view of how the brain works. I think that it's becoming increasingly clear that our consciousness has a somatic element. That's to say, it's embodied literally in our bodies. It's not just something that exists somehow in all the signals buzzing around in our brains. So it's not something you can encode into bits that you can download into a hard drive. It has to be in a body in order for it to be consciousness in the first place. So I don't think that that's something that's going to happen, that we're going to somehow download ourselves, our personality, into some hard disk.
Okay, well, once again, you've been listening to Philip Ball, author of the book Unnatural, the heretical idea of making people. So, Phil, thank you so much for being on Science Fantastic.
That's a pleasure. Thank you. It's very interesting.
And you've been listening to Science Fantastic with Professor Michio Kaku. Stay tuned as we continue to explore the cutting edge of science.
Be careful, Mr. Frankenstein. You toy with wrathful forces. And there's no mercy in nature.
Now,
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And on Science Fantastic, we throw the lines open so that you, the listener, can talk back on national radio. Okay, let's take the first listener phone call, please.
Hello, my name is Angel Suarez, and I'm calling from Reading, Pennsylvania, listening to the show on WEEU AM. And my question is technology already destroying or starting to kill off mankind? As science progresses and technology progresses, I notice that it seems to drive people out. Let's say you have an industry that is better done with a more sophisticated computer or better machinery that can do better or more efficient work than a human being. And when you drive out the human workforce, doesn't that lead to conflict among other humans, therefore knocking each other out of the way and fighting for the last piece of the pie? Will technology really push people to go to war and kill each other, and thus technology being left over, the lone survivor?
Well, you ask a very big question that's actually prominent in the presidential campaign, in economic discussions, as people discuss the impact of technology. Well, think back 100 years ago when we had blacksmiths and we had wagon makers. Well, where are they today? We don't have blacksmiths anymore. We don't have wagon makers, and for the most part, we don't miss them. We don't miss them because we don't need blacksmiths because most of us don't have horses. We don't need wagon makers because most of us don't have wagons. We have cars instead. And so in other words, the workforce changed. It didn't mean that we simply threw people out of jobs because they became auto workers. So we see what is called creative destruction. That is, technology, as you correctly pointed out, will destroy entire industries. However, it creates new industries in the process. So the key question is whether or not you can ride the surf, whether or not you can make the transition from an earlier technology to a new technology. And again, if you go back into the past, there were so many occupations that no longer exist, and we don't mourn them because society back then, 100, 200 years ago, was very inefficient, very expensive, and could not produce enough to empower the planet Earth. Today, however, we do have telecommunications that can empower billions of people. We have an industry which can create unlimited number of cars. But as you correctly pointed out, at some point, that too will undergo creative destruction. So what are we going to do? Instead of fighting for smaller and smaller pieces of the pie, I suggest we get a bigger pie. That's what technology does. Technology today creates an abundance of goods and services, so many that sometimes we can't even get rid of them because we produce so many cheap technologies. For example, this morning you had breakfast that the King of England could not have had 100 years ago. Think back. 100 years ago, the delicacies that you take for granted were very expensive. Only royalty could import delicacies from around the world. And today you say, anyone can get that. It's common knowledge that food prices have dropped. And so if you are in a job that may be headed for extinction, what are you going to do? Retrain yourself. Find out where the new jobs are. And believe it or not, even in this bad economic climate, there are jobs by the thousands that are unfilled. Let me repeat that again. There are thousands of jobs right now that are unfilled. Why? Because unfortunately, most American workers are not qualified to fill them. So if you're young, you're ambitious, what should you do? Retrain yourself. Go to a junior college. Go to a university. Learn the skills of the future. Don't mourn the past. The past is gone. Those technologies are inefficient, and they are going to be creatively destroyed. Go with the flow. Find out what industries are going to be flourishing in the future. And if you want to find out the names of some of these industries, get a copy of my book, Physics of the Future. I have a whole chapter discussing jobs of the future. Okay, let's move right along now. Let's take the next listener phone call.
Hi, this is Scott. I'm calling from Amarillo, Texas, listening on 940 AM, KHMR. Question is, how can we come to a theory of everything when the forces that occurred at the Big Bang probably changed the four major forces that we're dealing with?
Well, you ask a very interesting question that goes to the very heart of physics research. First of all, we have four fundamental forces, as you correctly pointed out. First is gravity, a very weak force that holds the solar system together. Then we have electricity and magnetism, which lights up our cities, creates telecommunications, computers, radio. Then we have the weak nuclear force, which governs radioactive decay. That's why we have uranium. That's why we have stars. Radioactive decay is used in hospitals as tracers. And then four, we have the nuclear force, which holds the proton together and holds the nucleus together. Four fundamental forces. And you asked the question, what about the instant of creation? Were there more forces then? Well, what we try to do is run the videotape backwards. When we run the videotape backwards, we see that the electromagnetic force combines with the weak interaction force, creating the electroweak interaction. Now, remember that Einstein thought that if you ran the videotape backwards, then electricity and magnetism would combine with gravity. Well, apparently Einstein had the wrong track. The weak force and the electromagnetic force unite first, creating the electroweak theory, which won the Nobel Prize for Steve Weinberg and Abdus Salam. If you run the videotape back even farther toward the Big Bang, then the strong force unites with the electroweak force, giving what is called the gut force, the grand unified theory. And then if you run it all the way back to the beginning of time, to the instant of the Big Bang, then all four forces combine, including gravity. That's why you need a theory of everything. A theory of everything includes gravity plus the other three quantum forces. Now, to be very blunt, at the present time, there is no universally accepted candidate for the theory of everything. The closest is string theory, but we're testing it, or we're testing the periphery of it, with the Large Hadron Collider outside Geneva, Switzerland. So we cannot say for sure that string theory is correct. String theory, however, does unify all forces, because all four forces are reduced to music, just different musical notes vibrating on a string. So to summarize, we think that at the instant of creation, there was only one superforce, a superforce governed by string theory. As the universe began to expand and cool, then gravity broke off. And as it cooled even more, then the strong force broke off. And now we're left with a very broken universe, the universe that we see around us today with mountains and valleys and comets and stars, a very broken universe. But at the beginning of time, there was only one superforce that set the whole thing into motion. Okay, and also I should point out that this theory, string theory, is what I do for a living. It's my day job. In fact, I'm the founder of string field theory, which is one of the main branches of string theory. Well, let's take another short commercial break.
You're listening to Science Fantastic with Professor Michio Kaku.
High-energy protons spilling over into our atmosphere.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. It's open mic in this hour. So, moving right along, let's take the next listener phone call.
My name is Robert McFarlane. I'm calling from Bridgeport, Connecticut. I am listening to you on 94.9 in Connecticut. My question was about relativistic physics and particularly the twin paradox and how exactly that could be explained in more simplistic terms. As it would seem that from the twin paradox, if you consider the relativistic idea of which direction the movement is happening from, seems like one twin would see the other person moving equally as much as the other twin sees the first moving.
Well, the twin paradox is perhaps one of the greatest paradoxes in all of relativity. People sometimes throw their hands and get headaches thinking about this, but there's a very simple resolution to it. First of all, take two twins. Put one on the Earth and send the other one in a rocket ship. The rocket ship blasts away, and according to Einstein's theory, time slows down for the rocket twin. So if you had a telescope and you could see the rocket twin blasting away, you would see that the rocket twin is slower, moves slower than normal, because time has slowed down. Well, then the rocket twin makes a U-turn and comes back to the planet Earth. Who's younger? Well, the answer is the rocket twin is younger because he blasted off, he accelerated, he turned around, and time slows down the faster you move. However, now let's look at it from the rocket's point of view. Let's say you're on the rocket, and the Earth looks like it blasts off. Well, of course, you're the one who blasted off, but it looks as if the Earth is moving away from you. It looks as if the Earth turned around, then the Earth came back, and as you look with a telescope at the Earth, they seem to be younger. Well, here is the problem, a problem which stumped many of the great scientists for many years until people realized that, yes, Einstein was right. If the Earth spun around and came back, then the Earth twin should be younger. The Earth twin moved. It should be younger. But who's really younger? The rocket twin is younger. Now, you may say to yourself, how can that be? Isn't it symmetrical? Here is the key facet. It is not symmetrical. That's how you can tell the difference between the rocket twin and the Earth twin. The rocket twin is younger. Why? Because he blasted off. He turned around. By turning around, he accelerated. And acceleration is not part of special relativity. So it's not symmetrical. The Earth twin, because he blasted off, turned around, he really did move. That's why you know that time slows down. Now you may say to yourself, well, all this is nice, but it's so crazy. How do you prove it? You can prove it with your cell phone. When a satellite goes overhead, the twin paradox works with you as one of the twins. You have a cell phone. You have a clock inside your cell phone. There's also a clock on the satellite whizzing right over your head. The clock in the satellite beats slower than the clock on the Earth. Einstein was right. Time slows down the faster you move. And that's why GPS works. If it wasn't for that fact, all the GPS systems of the Earth would be thrown out of kilter, and the Pentagon would not be able to fight wars. People would get lost when they're hiking. All of it would collapse if Einstein was wrong. But hey, Einstein was right. Get used to it. Once again, the number to call if you want to share your thoughts about science is 866-323-2129. And record a comment or question giving us your name, the city that you're from, and the call letters of your radio station, and perhaps you can get on national radio. Okay, moving on. Let's take the next listener phone call.
This is B. I'm calling from Sebring, Florida, and I'm listening to 730, and I would like to know, could we human beings be walking dynamos?
Well, B, in some sense, we're walking dynamos in the sense that we can create energy by motion. However, it's not much. How much energy can you extract from the human body? Well, maybe at maximum 30 watts. It's not much. For example, your brain gets hot because you think. Your brain radiates roughly 20 watts. So your body will radiate maybe 30 watts if you're walking down the street. And 30 watts is not a lot of energy. You can easily get 100 watts simply by plugging into the wall. Now, this is going to be important when we have wearable computers in the future. In the future, we're going to have all these gizmos attached to us, and who wants to have to replace batteries all the time? We will use a generator that converts your bodily movements to electricity, and your appliances in your clothing will then be energized by your bodily motion. Now, if you think about the movie The Matrix, the machines took over, we humans were put in pods, and what did the robots want? The robots wanted to use humans as batteries. But give me a break. The human only produces about 30 watts of power. That is simply not enough to energize the machine world of the future. Okay, let's take the next listener phone call, please.
Hi, this is George listening to you in Portland, Oregon on radio station KUFO 970 AM. My question for you is, does science have an explanation of how the water gets inside the coconut?
Well, we scientists realize that there are lots of very common things which seem to defy explanation, like which came first, the chicken or the egg, or how do you get water inside a coconut? You have to realize that the chicken and egg, we're not talking about having a chicken and an egg separately. They evolved together. So which came first? In some sense, neither came first. You go back millions of years into the past, you realize that there were spores back then, very primitive cellular structure. So the chicken and egg, in some sense, evolved together. And the same thing with water in a coconut. If you take a coconut that is mature, how did the water get inside? The problem is you have to run the videotape backwards. And when you run the videotape backwards, you begin to realize that water came up through the main stalk of the tree. And then you say to yourself, well, coconuts are way up there. How did water from the ground get way up to the top? And that's capillary action. Capillary action is very easy to demonstrate. You get, for example, a Coca-Cola and put a straw in it. You realize that Coca-Cola will actually climb up the straw a little bit, defying gravity. Now, replace the straw with an even smaller straw. And then you begin to realize that water will climb up all by itself even higher because of capillary action. Now reduce the size of the straw to a cellular membrane. Then you begin to realize that at that point it's extremely small, and then water will flow uphill and put water inside the coconut.
You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. It's open mic in this hour. So let's take the next listener phone call.
Hello, my name is Anthony Gurley. I'm listening to you out of from Rio Rancho, New Mexico. The radio station is 770 KOB out of Albuquerque, New Mexico. And my question was, I'm trying to explain to my daughter where space comes from. Light comes from somewhere. It comes from the sun. It comes from a light bulb. How do I explain to her where space comes from?
Well, if you could explain that to your daughter, explain it to me, because we physicists don't know. However, we have theories about where space came from. First of all, when we realize space, we think of it as being very big, huge, infinite in extent. But Einstein comes along and says, well, space could be curved. That is, if you go far enough and the universe curves enough, maybe you'll come back and repeat yourself. So there's a possibility that the universe could be a hypersphere of some sort. If you fire a flashlight in one direction, maybe eventually the flashlight will hit you in the back of the head because the light beam went completely around the universe. Well, then Einstein proposed a theory called general relativity. And in general relativity, there was a big bang that set the universe into motion. How much space was there in the Big Bang? Very little. We think that the universe was so small you could probably put it into your pocket. Or for that matter, the universe was probably even smaller than an electron, a point particle. So the universe, we think, was a very small object, and there was no space other than this tiny little dot, and it expanded and exploded 13.7 billion years ago to give us this great universe of ours. And then you ask the question, well, if space itself was born 13.7 billion years ago, then what is space expanding into? Well, we think space is expanding into a higher dimension called hyperspace. That is perhaps a 10 or maybe even 11-dimensional universe predicted by string theory, which we think is the theory that replaces Einstein's theory of general relativity. And that's what I work on. I work on professionally string theory. I'm the co-founder of string field theory, one of the main branches of string theory. So to answer your question, we think that originally there was this 11-dimensional arena. In this arena, bubbles formed. One of these bubbles was our infinite universe. And when the bubble expanded, that gave us the Big Bang. And the arena is big enough to perhaps give us other universes, a multiverse of universes, which is very similar to a bubble bath. So to answer your child's question, where does space come from? The short answer would be, we don't know. However, the long answer would be, we think that our universe started off as a bubble of some sort, and this bubble expanded, giving us the space as we know it. But it could be that there are other bubbles and other universes. Now, if you want more on this, get a copy of my earlier book, Parallel Worlds, which gives you a complete description of the multiverse of universes. Okay, well, unfortunately, our time is up for this segment of Science Fantastic. Stay tuned for the next segment. We're going to take a short commercial break. And after the break, we're going to continue with Science Fantastic with Professor Michio Kaku. Share your thoughts on National Radio.
You're listening to Science Fantastic with Professor Michio Kaku. Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Here's your chance to talk back to radio. If you've been hearing something about the news, about the space program, about developments in medicine, about archaeology, geology, physics, chemistry, but you don't have anyone to talk to, give us a call. Moving right along, let's take the next listener phone call, please.
This is Mike Etherton from Memphis, Tennessee. And I'm listening to 87.7 FM, and I'd like to know, is the moon traveling away from the Earth, or is the moon coming toward the Earth?
Well, Mark, we can actually answer that question. The moon is leaving the Earth, and it's leaving at a very slow rate. We're talking about, inches per year, but we can actually prove this using two developments. First, we have lasers. The astronauts who went to the moon back in the late 60s and 70s left a mirror on the moon. We actually shoot laser beams from the Earth that bounce off that mirror and come back to the Earth. Now, it takes a little over a second for light to go from the Earth to the moon, and back would take a little more than 2 seconds. So by waiting for the return trip and knowing the speed of light, we simply divide, and that gives us the distance from the Earth to the moon. And we know that distance to plus or minus a few inches. We also have mathematics, the mathematics of Isaac Newton. Isaac Newton says that there's something called tidal forces. If the moon were a dot, just a dot, it would in fact go around the Earth in a perfect ellipse or a perfect circle. But the moon is not a dot, it's an extended object. The gravity on one side of the moon is different from the gravity on the other side of the moon, and that causes tides. So tides are caused by the fact that the Earth is not a dot but extended, and the moon is not a dot but also extended. And if you do the calculation, you find out that extended objects like the moon should slow down and then start to increase their distance from the Earth. That is, it should leave the Earth. Now, if you run the videotape backwards, you find that the moon long time ago used to be much closer to the Earth than before. And that led people to believe that the moon came out of the Earth, which is actually correct. The moon was blown out of the Earth about 4.1 billion years ago and has been leaving the Earth ever since. But at such a slow rate that I wouldn't worry about losing the moon. Okay, moving right along, let's take the next listener phone call.
My name is Sal Baez. I'm calling from Fort Stockton, Texas, listening on Sirius XM Radio. I'd like to know if maybe with these wind turbine generators, if energy that the wind has and it's being diminished by these turbines, whether that has any effect on on the weather around the globe somehow?
Well, you ask a very interesting question because more and more we see wind farms dotting the landscape. If you go to Europe, for example, you see that the Europeans have put a lot of money into building wind parks. And some of these windmills can actually generate about 1 million watts of power. That's an enormous amount of power coming from just one windmill. So given the fact that a windmill park can generate almost as much energy as a nuclear power plant, you might say to yourself, well, doesn't that affect the planet Earth itself? Doesn't that affect the atmosphere? Well, yes, but it's a very small effect. Let's say I have a helicopter, and I look down from the helicopter and look at all these windmills. And then I look at all the wind around me in 3 dimensions where the wind is blowing. Then you begin to realize that the amount of energy of the wind that hits the windmill is only a tiny fraction, almost an infinitesimal fraction of the total amount of energy stored in the wind moving in 3 dimensions. And so sitting on the earth looking at all these windmills, you say to yourself, oh my God, look at all these turbine blades spinning so rapidly. It must be so much that it affects the weather itself. But from a helicopter, you begin to realize that it's nothing. It's basically nothing compared to the energy stored in 3 dimensions with the wind, clouds, and other atmospheric disturbances. Okay, well, let's take another short commercial break. Once again, this is Science Fantastic with Professor Michio Kaku. Give us a call. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, this is Open Mic on Science Fantastic. Well, let's move right along. Let's take the next listener phone call, please.
My name is Robert. I'm from Atlantic City, Jersey. I'm listening to XM 168. And my question is, all black holes are so powerful, the gravity is so powerful that no light or energy or anything escapes black holes except for X-rays. X-rays seem to escape. Why is that?
Well, you ask a very interesting question, and it goes to the heart of the contributions of Dr. Stephen Hawking, my colleague, who is totally paralyzed, but using the power of his mind, he's able to create new physical theories. First of all, let's define a black hole. A black hole is an object that is so massive that even light itself cannot escape, and therefore it's black from the outside because it emits no light. It was first proposed, believe it or not, way back in 1916. Einstein proposed relativity theory in 1915. The year after that, Dr. Schwarzschild found a solution of it, and lo and behold, it is the black hole solution. So we've had black holes for quite a while, but Einstein himself was skeptical whether these black holes could actually form. Well, the person who solved that problem was none other than Robert Oppenheimer. Back in the 1930s, he realized that stars could collapse, and the sudden collapse of a star could create enough mass concentrated at a point such that light could never escape and the object would be black. By the way, that kind of process, the implosion of a star, actually was used by Robert Oppenheimer just a few years later to build the Nagasaki bomb. The Nagasaki bomb is based on imploding plutonium, much like Oppenheimer imploded a star just a few years earlier. Well, then, back in the 1950s and 60s, we despaired of ever finding one of these things because they're black after all. How do you find a black object in outer space? And then we begin to realize that, well, black holes spin. They spin very rapidly, and as gas swirls around the black hole, the gas should be visible. And bingo, lo and behold, we have now found thousands, maybe millions of black holes lurking in the center of galaxies. Now, then Stephen Hawking comes along and says, not so fast, not so fast. Maybe they're not totally black. Maybe they're gray. Maybe they seep out gently a ripple of radiation called Hawking radiation. So Hawking said that in quantum theory, that is the theory of the atom, we have uncertainty. All processes must have a slight amount of uncertainty, including black holes. You see, blackness is a perfection of nothingness. It's not uncertain. Hawking says, now wait a minute, that violates the uncertainty principle. Everything should be uncertain, even the energy coming out of a black hole. So he did the calculation, and boom, there it was. He found that radiation will gently seep out of a black hole, not just X-rays, but all frequencies. This is called black body radiation, and it depends on the temperature of the black hole, but you can get all forms of radiations gently seeping out of a black hole. Now, it's very sad to say that Stephen Hawking probably will not get the Nobel Prize for this idea. Every physicist believes it's correct because it uses quantum mechanics to describe black holes. But Hawking radiation is so faint that it cannot be detected by our instruments. So the Nobel Prize Committee, being very conservative, says you have to have proof. Where's the beef? You have to have proof. And the Hawking radiation emitted by a black hole is simply too faint to be picked up by our instruments. And so even though universally we believe that Hawking was right, there's no smoking gun that clinches it. But the radiation is more than just X-rays. The radiation could be of all forms. It's called black body radiation that is emitted from a black hole. Well, we have a few minutes left on Science Fantastic, and I'd like to answer some of the emails that I get. I get a lot of emails from people. Mainly, if you want to get on Science Fantastic, why don't you call our magic number, 866-323-2538. But some people email me, so let me answer some of the questions that I get. One of the questions involves the Mars Curiosity rover, perhaps the most expensive, the most elaborate science instrument ever placed on another planet. I like to think of Curiosity as the Godzilla of space probes. It has 10 times the instrumentation of previous probes. It is 10 feet long, meaning that it is twice as big as any of the previous space probes. And people say, well, what are we going to get from it? What we will get from the Mars Curiosity space probe is hopefully proof that water once flowed freely on Mars, liquid water. And liquid water is a universal solvent. It's where life got off the ground. And so one of the big goals of the Curiosity rover is to show that Mars once upon a time had great oceans, and with that is the possibility that maybe, just maybe, microbial life also got off the ground. Well, unfortunately, that's it for Science Fantastic. Once again, every week on Science Fantastic, we talk about the cutting edge of science. Good day.
You're listening to Science Fantastic with Professor Michio Kaku.